Hi, this is John Linneball from John Linneball Tutoring, and this is Barron's Chapter 6M, Solid Geometry. Here's my contact information, which will be repeated at the end of the video. For best results, use the Barron's SAT 30th or 29th or even the 28th edition. This video covers pages 613 through 614 in the 30th edition of Barron's SAT, the Premium SAT Study Guide. The page numbers are the same in the 29th edition, and they're identical or close enough in the 28th and previous editions. You shouldn't use an edition older than Barron's new SAT from 2016, which I believe is the 28th edition, in any event. Notice, not everything in the book is in these questions. Do read the book. The older editions of this book can be had cheaply, if not for free, from used booksellers, kids who've already taken the test, and public libraries. They sell old editions, or you can borrow the current edition. If you plan to use a library copy or a new edition, I suggest you start early. There's no worse feeling than needing a library book someone else has checked out, or trying to buy a review book that's sold out at a local bookstore. You know, if you start a few days before, that 2 days for shipping from Amazon or whatever can really eat into your time, so plan ahead. Alright, so let's go ahead here. Question 1, page 613. What is the volume of a cube whose surface area is 54 square inches? Well, we know the surface area of a cube is the total area of each surface or face, so each one of these big squares here. So the surface area is 6 times the square of the edge length, so this would be the edge length. Obviously, the area of one of these squares is just this edge times another edge. Since they're all the same, it's just this squared. Get it? Ha ha ha. So the surface area is 6e squared, because there are 6 of these faces, which is equal to 54 inches squared, or 54 square inches. So e squared is equal to 9 square inches, because we just divide through by 6. So e squared is equal to 9 square inches. So e is 3 inches. Since the volume of a cube, e cubed, get it? You know, the width times the height times the length, width, height, is e cubed. Get it? The volume is 3 cubed, which is 27, which is choice A. All right. Question 2, page 613. What is the surface area in square inches of a cube whose volume is 1,000 cubic inches? This is just the previous question, question 1 in reverse. Since we know the volume is the edge cubed, so it's this times this times this, it's 1,000 cubic inches. 1,000 inches cubed, or cubic inches, is equal to e cubed. So we just take the cube root of each one. We know the cube root of 1,000 is 10. So are we done? Well, no, because we still have to figure out the surface area of the cube. So the surface area of the cube is 6e squared. So the surface area of the cube is 6 times 10 squared, which is 600, choice D. All right. Question 3, page 613. 2 solid metal spheres, so they might be like these Benoit balls here, each with a radius of 1 inch, are placed in a rectangular tank whose length, width, and height are 3, 5, and 6 inches respectively. To the nearest tenth, what is the volume in cubic inches of water the tank can hold? Well, first of all, the volume of a sphere is 4/3 pi r cubed. So the radius, of course, would be from the center of this Benoit ball to the edge. And so the volume of each sphere is just going to be 4/3 pi. Why? Because they say it's 1 inch. So 1 inch cubed is just 1 cubic inch. And so it's 4/3 pi cubic inches. So their combined volume is 8/3 pi cubic inches. I should have the units here. Since the tank is rectangular, the volume is the length times the width times the height, which is 3 times 5 times 6, so 3 inches times 5 inches times 6 inches, which is going to be 90 cubic inches. Again, should have put the cubic inches as the unit there, but I didn't. Oh well. So the volume of empty space in the tank is 90 minus 8/3 pi, all in square inches. 90 minus 8.38 is approximately 81.6, or choice D. And again, I do suggest that you go and look at the actual book and the exercises. You're not going to learn everything you can just by watching this video. Please do get the Barron's book and read it. Anyway, question 4, page 613. The height, h, of a cylinder is equal to the edge of a cube. Okay, so we can see the height of the cylinder, and that's going to be the same as this edge of this cube. These are just two drawings I got off the internet. This is probably not really equal to this, but oh well. Anyway, it's equal to the edge of a cube, so all of these in our world are equal to this. If the cylinder and the cube have the same volume, what is the radius of the cylinder? Alright, so we know the formula for a cylinder's volume is V equals pi r squared h. Makes sense, because it's just going to be the area of the circle, pi r squared, times h, just multiply it by the height. So that makes perfect sense. So let's call the cube's edge E. So this is E here. Here's E, here's an E, here's an E, there's an E. The cube's volume is E cubed. Get it? Ha ha ha, E cubed. Anyway, so E cubed is equal to pi r squared h. Since E is equal to h, we know that h cubed is equal to pi r squared h. Dividing by h, we get pi r squared is equal to h squared. So then r squared is equal to h squared over pi, and r is going to be equal to h over the square root of pi. So r squared is equal to h squared over pi. We just take the square root of each side here. So you end up with r is equal to h over the square root of pi, which is choice A. Question 5. All right, question 5. Here we have a funky Rubik's Cube type cylinder. I don't think this would really work as a Rubik's Cube or Rubik's cylinder, but whatever. It's not that important. So, if the height of a cylinder is 4 times its circumference, what is the volume of the cylinder in terms of its circumference, c? Well, alright, we know the circumference is always going to be 2 pi r. It's also just pi times the diameter, and since the diameter is 2r, we know the circumference is 2 pi r. And of course, I skipped over the volume here. Volume is, again, pi r squared times h for any cylinder. So that means if we manipulate the equation that relates a circumference to the radius, c equals 2 pi r, we can divide c by 2 pi and 2 pi r also by 2 pi. Divide both sides by 2 pi is what I'm trying to say. And you end up with r equals c over 2 pi. Now what we can do is substitute c over 2 pi into this equation here where we see r. So v is going to be equal to pi r squared 4c, and then when we substitute it in, it ends up being pi times c over 2 pi, that whole expression squared, times 4c. Of course, when we square this, we end up with c squared over 4 pi squared. When you multiply that by pi, so you're going to end up with c squared pi over 4 pi squared. So you can see that this pi and one of these pi's automatically cancel out, so we end up with c cubed, because we're multiplying times c. So we have c squared times 4c, so that becomes, okay, c squared times 4c, so you have these c's, so you have a c cubed. There's a 4 on the top and a 4 on the bottom. Those cancel out, so again we end up with c cubed times pi, which is choice A. I'm sorry. I made a mistake. It's c cubed divided by pi, which is choice A. So again, in case you didn't get it, okay, we have pi r squared times 4c, substitute in c over 2 pi, c over 2 pi squared, and times 4c, that becomes c squared times pi over 4 pi squared. I'm going to multiply that by 4c. We can see, haha, no pun intended, that this c goes with these other two. That becomes c cubed, because it's c times c times c. And then this pi on the top cancels out one of the pi's and pi squared, so we just end up with c cubed over pi, which is choice A. All right. Question 6, page 613. What is the volume of a pyramid whose base is the square of area 36 and whose 4 faces are equilateral triangles? Okay, obviously this isn't a square, these are not equilateral triangles, it's not drawn to scale. So just imagine if the problem said, note, figure not drawn to scale. Anyway, so we know that this is a square of area 36 and these are equilateral triangles. So the volume of a pyramid with a rectangular base is V equals 1/3 L times W times H, where L and W are the length and the width of the base. So this would be the length, this would be the width. And H is the height from the center of the base to the point of the pyramid. So that's this red thing right here, this red line. So since the base is a square and the area of the base is 36, L equals W equals 6 because it's a square. So all four sides are equal. Pretty easy to take the square root of 36 to get 6. Since the faces are equilateral triangles, that means each side of each face is also 6. This is 6, 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 this is 6. Wow, that's a tongue twister, huh? Okay. Just like the six sheep's 6. Okay, anyway. Alright, so question 6 continued. So, we need to find H to solve the problem. How? Well, it's simple, but it's not exactly easy. So let's pretend we're in drafting class, mechanical drawing, whatever you want to call it. We're going to look at this pyramid from a top view. So we can see the square base, we can see this point in the middle. So the diagonal of the square base, since this is 6, this is 6, this becomes 6 root 2. So anyway, we know that that's 6 root 2. So that means half of this has to be 3 root 2. So this is 3 root 2. Alright, so from the problem, we know that each side of each triangular face is 6, so we can see the height, half a diagonal, and a face form a right triangle with hypotenuse equals 6, and one leg equals 3 root 2. Okay, this says 6 root 2 here. That's a mistake. This should be 3 root 2. So this is 3 root 2, this is 6. So then we know that a squared plus b squared equals c squared from the Pythagorean theorem. This is c. This you can make it a or b, it doesn't really matter. Anyway, so we know that 36, which is 6 squared, is equal to 3 root 2 squared, which is going to be 9 times 2, which is 18. So, because you square the 3 and then you square this, the square root of 2, so you end up with 9 times 2, which is 18, plus Oh, and I messed up here too. This shouldn't be h. H should be the hypotenuse, but oh no, it's like that old joke. I thought I was wrong once, but I was mistaken. No, this is c. This is correct because this is h. It's the height here, not the hypotenuse. All right, hope you're hanging in there. Anyway, we know that this squared is 36, this squared is 18. You subtract 18 from 36, you should be able to figure out that h squared is also 18. Therefore, h has to be equal to 3 root 2. So this is actually an isosceles right triangle. So we know that this is 45, this is 45. And because this is going to be 3 root 2, 3 root 2, and this is going to be 3 root 2 times root 2, which is 6. So anyway, how does that help us? Well, we know the volume from before is 1/3 L times W times H. We know that W times, length times the width is just going to be 6 times 6, that's 36. And then we know that this is 3 root 2, so H is 3 root 2, so it's just 1/3 times 36 times 3 root 2. Obviously, 1/3 times 3, those cancel out, so you just end up with 36 root 2, which is choice B. And alright, let's move on to the next one. Question 7, page 613. An isosceles right triangle. Hey, we have this isosceles right triangle again. So we know isosceles right triangle, you should automatically know 45, 45, 90. Why? Because it has equal legs. That's what isosceles means. And obviously equal legs means that the angles across from those equal legs are also equal. If you know this is a right triangle, then the other two angles have to add up to 90, so it's got to be 45, 45, 90. So this is rotated around one of its legs to generate a right circular cone. So you end up with something that looks like this thingy down here. And they want to know what's the volume of the cone. Well, we know the volume of a cone is V equals 1/3 pi r squared h. Alright, so we know that this is h. And since the triangle is isosceles, that means this is 6, and this is 6 root 2. So what we're going to do is basically we just know that the radius is equal to 6. So pi r squared, okay, so that's going to be 36 pi times 1/3 times 6. All right, we know that 1/3 times 6 is 2. We know that, so it's just going to be 2 times 36 pi, which is 72 pi. So again, the volume is A equals 1/3 pi times 36 times 6. Boom, just, the 1/3 and the 6 cancel out, so you end up with a 2. So pi times 36 times 2 is 72 pi, which is answer B. All right. And question 8, page 613. The sum of all the lengths of the edges of a cube is 6 centimeters. What is the volume in cubic centimeters of the cube? Well, the easiest way to do this is literally just draw a little doodle, a little sketch of a cube. So then when you're done drawing it and you make it see-through like this, so you go, okay, how many edges do I have? Well, I see there are 4 on top, and then there are 4 in the middle. These ones, these are the height. And then there's 4 more on the bottom, so that means there are 12. Okay, so then I just divide 6 centimeters by 12, and then I know, oh, the edge length is just 1/2 of a centimeter. So the volume is going to be 1/2 of a centimeter cubed, and then 1/2 times 1/2 times 1/2 is 1/8. Or you can just go 1 over 2 cubed, which is again 1/8. So there's our answer, 1/8 of a cubic centimeter. Question 9, page 614. A 5-foot long cylindrical pipe has an inner diameter of 6 feet and an outer diameter of 8 feet. If the total surface area inside and out, including the ends, is k pi, what is the value of k? All right, since it's a grid-in question, they can't really expect you to put in pi, and they don't want you to have to estimate it using 3.14. So that's one way for them to get away from doing that. So we can start with the ends. Since the inner diameter is 6 feet, so this is 6 feet here, and the outer is 8 feet. So from here to here is 8 feet. Okay, so that means we've got a pipe that's inner dimension is 6 feet across, and this is 8 feet across. So we can tell that the pipe itself is about a foot thick. Well, it is exactly 1 foot thick. So this is a gigantic sewer pipe or something like that. Anyway, we can just subtract the area of the inside end, that is the hole in the end, the 6-foot diameter hole, from the area of the outside end, which would be the end of the 8-foot diameter end, and that's the thickness of the pipe. So the radii of the outside and the inside are, this is going to be, okay, the outside and inside, so this is 4 feet from the center to the outside, and then it's 3 feet to just the end of the inside. So alright, so we know areas pi r squared, so the area of the outer end, the area of the inner end, or minus the area of the inner end, is going to be 16 pi, so it's 4 squared times pi, minus 9 pi, which is 7 pi. Since there are 2 ends, their total is 14 pi. Anyway, the surface area of a cylinder is C times H, where C is the circumference of the end of the cylinder and H is the height. So you can think of unwrapping the label from a soup can. It'd probably be better to do it a little more neatly than they do it in this picture here, but anyway. So it forms a rectangle where one side is C, so it'd be the circumference of the soup can, for example, and the other is H, so that would just be the length, well, no, it wouldn't. The circumference would be the length of the soup label, and this would be the height of the soup label from the top to the bottom. So it works the same way with this pipe here, like the sewer pipe that we've been talking about. So we can multiply the diameter by pi to get C, Or we can use 2 times the radius, which is the diameter, and multiply that by pi to get c. So here we have an inner surface area of 6 pi times 5, which is 30 pi, and the outer surface is 8 pi times 5, which is 40 pi. The total is 70 pi, and when we add the ends, we get 70 plus 14 times pi, which is 84 pi. Therefore, k is equal to 84. So, question 10. What is the number of cubic inches in 1 cubic foot? Here's the easy way to do it. Know that 12 inches is equal to 1 foot. So, and then you're just going to cube 12. So let's take this little diagram here. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, okay. Ideally we'd have 12 here, but we don't. But you see the principle is just each one of these, if this is 1 foot, you can divide it into 12 inches. You can divide this into 12 inches. You can divide this edge into 12 inches. So, 12 cubed is just 12 times 12 times 12. My guess is this would just be on the calculator section, so you can use the calculator section. It's pretty easy. You can just go 12 and then hit the cube thing, and it's 1728. If you have a calculator or you're feeling insecure, maybe you have a 4-function calculator even though you're not supposed to use that, you can go 12 times 12 is 144 times 12, times 12, and you'll get 1728. If it turns out that it's on a non-calculator section, you should know that 12 times 12 is 144. I strongly suggest you know your squares from 1 to 20 for the SAT or the ACT, or at the very least up to about 15, and you want to multiply that by 12. So you can just take 144 and then multiply it by 12, actually writing it down inside your test booklet or something if you have to. Anyway, no matter how you do it, the answer is 1728. Okay, so we're going to get rid of this calculator. Question 11, page 614. A rectangular tank has a base that's 10 centimeters by 5 centimeters and a height of 20 centimeters. If the tank is half full of water, by how many centimeters will the water level rise if 325 cubic centimeters are poured into the tank? First, you should note that the water level makes no difference unless the tank is small enough that adding an extra 325 cubic centimeters will cause the tank to overflow. In this case, the volume of the tank is pretty easy to figure out. It's 10 times 5 times 20, so that just becomes 50 times 20, which is 1,000 cubic centimeters. So notice that 1 centimeter is equal to 1 milliliter, so 1,000 cubic centimeters is 1 liter. So half full is 500 milliliters, and adding 325 milliliters will just make it 825 milliliters. Since we know it's not a trick question, we can just pretend that the tank was empty. Since the base is just 5 times 10 square centimeters, which is 50 square centimeters, we know that whatever you pour into it, it's only going to go up whatever the volume is divided by 50, because it takes 50 square centimeters to coat each part of the tank is what I'm trying to say. Anyway, so we can just divide 325 cubic centimeters by 50 should be 50 square centimeters, not 50 square cc's. Oops. Anyway, 325 over 50 is going to be 13 times 25 over 2 times 25, which is 13 over 2, which is equal to 6.5. Either answer is fine. Doesn't matter if you grid it in as 13 over 2 or 6.5. Then, question 12, page 614. 3 identical balls fit snugly into a cylindrical can. When I saw this problem, I was like, hey, that's like a tennis ball. It's like 3 tennis balls inside a canister. So, the radius of the spheres equals the radius of the can, and the balls just touch the bottom and the top of the can. What fraction of the volume of the can is taken up by the balls? Okay, as I said, this is the way tennis balls are packaged. Let's assume that these balls have a radius of 1. So since they're all identical tennis balls, they all have a radius of 1. Alright, we know from doing previous problems that that makes the volume of each ball equal to 4/3 pi r cubed, and since r cubed is still going to be 1, it's just 4/3 pi. So, we can see the height of the can is 6 times the radius of one ball because you can go radius, 1, 2, 3, 4, 5, 6. Just divide 3 by 1/2. You divide it into little half diameters. So the height of the can is 6 times the radius of one ball, or it's 3 times the diameter of one ball. So the volume of the can is V equals pi r squared h. Pi times 1 squared times 6 is equal to 6 pi. Since there are 3 balls, the total volume of the balls is 4/3 pi times 3 equals 4 pi. So the fraction of the volume of the can occupied by the balls is 4 pi over 6 pi, which is 2 over 3. So you would grid in 2 over 3. You could grid in 4 over 6, but do yourself a favor, reduce fractions, or use the decimal. Did you find this video useful? Well, if you did, please like it and subscribe to this channel. Neither action costs you anything. You'll be alerted about my new videos. Why do I care? Well, it's simple. YouTube doesn't let me share any ad revenue unless I have 1,000 subscribers and 4,000 hours of view time in a year. While many people are watching these, I don't have 4,000 hours of watch time. And I still don't have anywhere near 1,000 subscribers. Last I checked, I had about 693, so need another 307 subscribers. Please help me out. Copyright issue. If you think that I've infringed on your copyright, I'm using something yours without permission, please contact me and let me know. For the same reasons, you are not only welcome, but encouraged to share links to this video, put it in playlists. As long as you give me credit for it, go ahead and copy it. I'm pretty sure if the copyright issue, I'm not using anything that isn't public domain, Creative Commons, etc., fair use. But if you have a problem, let me know. And if you want to use it, just say, hey, John, I want to use it. And I'll probably just say, yeah, go ahead and do it. Just give me credit for it. Anyway, I'm always happy to read and respond to constructive criticism or suggestions for a new video. I reserve the right to delete comments from and block those who specialize in destructive criticism, trolls, or things that are off topic, spammers, disturbed people, whatever, multi-level marketers. Anyway, you can contact me on my cell phone, 415-623-4251. You can call, you can text, I don't care. Email me, john@johnlinnebaugh.com. Mail me at 1859 Powell Street, number 109, San Francisco, California, 94133. Thanks very much for watching. And if you need even more contact information, you can find me on Facebook at facebook.com/Linnebaugh Tutoring. Instagram, you can find me at www.instagram.com/John Linnebaugh Tutoring. Another phone number is my office phone number, 415-986-7355. And email again, john@johnlinnebaugh.com. And my website is, of course, www.johnlinnebaugh.com, or if you go to www.johnlinnebaugh.tutoring.com, takes you to the same website. All right, hope you enjoyed this, and have a good day.